In part three of the presentation, I want to talk about geological hazard avoidance and mitigation. And I want to talk in three parts of this discussion about first earthquake fault zones, liquefaction, and tsunamis. And then in part four, I want to talk about zones of volcanic activity and land subsidence. And then finally, in part five, I want to talk about steep slopes, landslides, and rockfall, and saltwater intrusion. In terms of earthquake hazards, the hazard is really movement at the interfaces of continental plates. This movement, as is illustrated in the diagrams in the lower right, can be vertical or it can be horizontal. Vertical movement consists of dip slippage, as we see in the middle diagram, where the continental plates move vertically relative to one another, where one of them slides down along the edge of the other plate. A thrust fault is also vertical action, but in that situation, one of the plates slides above the other plate. And then secondly, we can talk about horizontal movement, which is called strike slip fault, as is illustrated in the lower right-hand diagram, where the plates move horizontally rather than vertically. There are significant earthquakes throughout the United States. We have a tendency to think of earthquakes as something that happens on the West Coast and in Alaska. But in fact, we have had earthquakes not only in the far west coast along the Pacific Coast Range and the Interbasin region, also in Idaho, western Wyoming, Montana, and Utah. And most interestingly, one of the largest earthquakes we've had occurred in a place called New Madrid in southeastern Missouri, and there was an earthquake in South Carolina. The material at the upper right shows the magnitude of earthquakes that have occurred in the United States. The largest magnitude is on the Richter scale, which measures magnitude of earthquake. Prince William Sound in 1964 in Alaska had an earthquake with a magnitude of 9.2. The 1906 San Francisco earthquake was 7.7. The New Madrid earthquake in 1811 was between 7.2 and 7.7, depending upon what source you look at. And similarly, the Charleston, South Carolina earthquake in 1886 had a Richter factor of Richter score between 6.9 and 7.3. So while earthquakes are more prevalent in the western part of the United States, it is not as if there is no threat in the eastern portion of the country. This map illustrates earthquake hazard within 50 years. This is the likelihood of hazard occurring subsequent to 2014 within the next 50 years. We can see that the majority of the area on the map is in fact in the western United States, but we see a very dark area in the New Madrid fault and also a fairly dark area in Charleston, South Carolina. What this suggests is that in the areas that are orange to red to dark brown, the hazards over the next 50 years are higher than areas that are beige in color or gray. The San Andreas fault in up and down the east coast of west coast of California in the Pacific Coast Range represents a strike slip fault, that is horizontal movement, where land is moving horizontally along the San Andreas fault. This was the fault along which the 1906 San Francisco earthquake occurred. And you can see in these images some of the damage that occurred to buildings, individual structural damage to individual buildings. And then in the upper right, we see massive areas of San Francisco that were completely leveled by the 1906 earthquake. And in the lower right-hand diagram, an extensive fire. We can see scars, and not really scars, but manifestations of the San Andreas Fault in the landscape today. And we see these long linear scars, some of which are filled with water, others are simply slits in the landscape. One of them runs right through the middle of the San Francisco Bay Area. This area, the Back Bay area, is part of the San Andreas Fault Zone. And the San Andreas Fault then runs on north up into the county immediately to the north and then on up through the northern part of California. This map shows a couple of things. First of all, the fault zones in Yuma County are mapped, and they are numbered from 1, the Kotla Fault Zone, which is in the northern part of Yuma County, to 12, the Sierra Pinta Fault Zone. So this map maps fault zones within Yuma County with the assistance of geologists and geological engineers. And then the lower right-hand diagram indicates liquefaction hazards. And I will talk more about liquefaction in just a minute, but you can see that in 1940 in Yuma County, there was a significant amount of liquefaction damage associated with earthquake activity. Liquefaction is a process where water saturated granular sands and gravel that are underneath of a fairly dense sediment layer can become active and can come up to the surface of the land if an earthquake occurs, fracturing the overlying sediment layer. And the liquefied sand then is under pressure, and when the fissures open up as a result of the fracturing of the overburden relative to the water saturated granular layer, then that wet sand will flow upward and move across the landscape. But we can see in the upper left-hand diagram, this manhole cover is filled with mud. This is the liquefied sand that has flowed up through the fissures from the liquefied sand material underneath of the now fractured material. On the right-hand side of the diagram, we see building damage associated with the fact that essentially the foundation now of these buildings is sitting in liquid sand, and the structural support for the building has completely been undermined. And so the buildings then literally have toppled over, creating extensive damage. The diagram in the lower left then shows Yuma County in Arizona, and the red area shows the area of liquefaction damage during during an earthquake occurring on May 8, 1940. The yellow area shows areas that are still susceptible to liquefaction hazards. This map shows liquefaction hazards. Right-hand map, these areas are subject to liquefaction problems when earthquakes occur that fracture the underlying sediment, releasing the liquefied sand underneath of the sediment. And then the map on the left-hand side of the image shows not only liquefied hazard zones along Trabuco Creek, but also landslide hazard areas in the rest of the municipality. Tsunamis are tidal waves that occur as a result of underground earthquakes. The underground earthquakes generate a tidal wave that flows across the landscape. And in this case, then we're seeing that portion of Honolulu, Hawaii, that will be impacted by tsunami waves.